All right, 17 and 18 both use this graph for reference. So the graph of f is shown below it, which of the following points is f continuous. So let's just do process of elimination here. We go to -3, -1, 2, 3. Oh, that's a vertical asymptote. So obviously we're not continuous at a vertical asymptote. All right, what about at x equals -1? At x equals -1, the function breaks apart. Remember, the definition of continuous is you can basically, or the informal one is that you can basically draw it without having to lift your pencil, which is certainly not possible here. So at -1, not continuous. All right, what about at x equals 1? Okay, looks pretty good. Stay tuned. Let's check the next one. X equals 1, 2, 3. What happens is the function breaks apart, jumps up here, and then comes down, right? So it's not continuous at x equals 3. So our answer is C, x equals 1. And then number 18 is asking about which from problem 17 has a removable discontinuity. So -3, not removable because it's this vertical asymptote. So what removable discontinuity means is we could basically take a single point and fill it in where the function's discontinuous and then suddenly make it continuous. So we can't do that at -3 because it just breaks apart and goes off to infinity and negative infinity. We can't do it at -1. We can't put a single point here because there's several points between the two pieces of the curve. So those two are no good. And then at x equals 0, it's not even discontinuous. It's a continuous function at x equals 0, so that can't be an answer. And then at x equals 1, we said it's continuous in part A, so it's continuous right there, so that's also not a removable discontinuity. So it must be at x equals 3, and that's because we can just take a single point and fill it in right here where it's discontinuous, and now it's continuous. So that's why we call it a removable discontinuity.